I know what you think. Why should I care about UIKit when SwiftUI is making so much progress and is getting so much traction? One of the main reasons is SwiftUI is not mature enough at this point. It's very easy to get started. It's very easy to write clean code for the most part. But some things are kind of hard to get right, especially if you want more granular control. This is why UIKit is still relevant today, and it's very important for you to learn and get right. Also, there are many mature projects out there that were written way before SwiftUI was even born. And those projects need to be maintained and need to be worked on. For all these reasons, my favorite approach to writing modern apps using SwiftUI is to use a hybrid approach. Use SwiftUI for designing the view part and the view models, and use UIKit for the rest, like coordinators, view controllers, navigation, and so on. And now that we hopefully agree that UIKit is still very important to learn, I want to show you one of the most important things when writing iOS apps, and that is the viewController Lifecycle. Why is this important? Well, it turns out view controllers have all these functions that can be overridden, and you can get notified of certain events, like when a view bounds change, or for example, when you rotate the device. In this case, if you rely on the view bounds to position certain elements absolutely, or if you have some animations or some custom drawing, and you probably want to animate those changes alongside with the rotation of the device. There are also other things that might be interesting. For example, when a view disappears off screen, you might want to stop polling any data or pausing any animations that you got going on, and resume those once that view gets back on screen. Not having knowledge of the viewController lifecycle can lead to some pretty weird bugs, and we've all been there with trying to debug some issues that simply don't make sense. I think every iOS programmer needs to understand the view lifecycle in order to build fast, scalable, and reliable iOS apps. Not giving enough attention to this is basically throwing away what the iOS platform engineers are giving you for free to help you out. In order to better illustrate this, I've created a project that I am linking in the description down below and go through all those stages so that you can understand how the viewController lifecycle works. And let's analyze a few common scenarios. So I've created this simple project, and it basically just has a single viewController. I have some basic logic here to create an identifier for the viewControllers so that I can reuse the same viewController over and over and print out certain stages of the lifecycle. I didn't use a storyboard for this. I instead opted for using a nib with just 3 buttons in the middle. One of them will open the same viewController using a modal presentation. Another will push it to the navigation stack, and another will simply show an alert so that we can debug some more stuff. Again, you can find this resource in the description of this video. I basically implemented the most important methods. First of all, you have the init when the viewController is first initialized. You then have viewDidLoad, which tells you that the view was actually loaded. And then all of the rest of the methods, like when the view will appear, when it appeared, when it transitions. This is useful when, for example, rotating the device. You might want to animate some changes on your viewController alongside with the rotation. And you already started to notice this kind of pattern of the system notifying you before it's going to make a change and after that change was complete. You can use this in your advantage. For example, if you want to add something to the view before it's displayed, you can use the viewWillAppear method and override that. And if you want to, for example, start polling an API once the view has actually appeared, you can use the viewDidAppear function for that. Then you have when the safe area instance did change, if you're interested in that. Layout margins, similar to this one. These happen very often when you rotate the device. You'll actually get new margins and new safe area insets, depending on if you're on landscape or on portrait. And then you have some actions that basically tie up to those buttons that I showed you earlier in the viewController. So let's give it a go. I started up the app, and the first thing that it did is initialize that navigation controller and add this initial view controller with the ID of 1 as the root view controller. And that triggered some things over here. So all of these are in a specific order, depending on how the system set up the UI as it progresses to the app and as the events come in. So you can see that the first message is init, then it loaded the view and you got the notification for viewDidLoad. And then you have viewWillAppear. This is happening before the view will actually appear. It's been loaded, but it's not on screen yet. viewDidLoad is guaranteed to be done only once because the view controller would load its view only once. But viewWillAppear and viewDidAppear will be called many times depending on, for example, if you push another view controller onto the stack and get back to it, viewWillAppear will be called again. So what you want to do is initialize your views in viewDidLoad, but if you have anything specific that needs the UI to be laid out, or at least you need the frames to be calculated, you will want to do that in viewWillAppear or the other ones, depending on your specific case. One of the reasons why I didn't use storyboards and nibs instead is because in the nib file, I set its view to be of a pretty atypical freeform frame size. So then when you look at the logs, you can see that in the viewWillAppear, the views frame has changed from the original one that I set up in the nib, the screen size. So going further, you see that after the viewWillAppear method was called, some things are still not calculated. For example, the safe area insets and the layout margins. This view controller might be the child of another view controller. So whenever that parent view controller decides to change the frame of your current one, you'll basically want to be on the lookout in these methods for any frame change. And then finally, you will get the callback that the view was actually successfully displayed. It was attached to the window. Everything is on screen. What we'll hear, let me show you what happens when you, for example, rotate the device. Rotate. And we can see that some things came up here. So view will transition to the new size of the screen. I also printed some things here. It gives you a coordinator, which is of type UIViewController Transition Coordinator. And you can use this object to get access to some interesting variables, how long the transition will actually take place. So if you have an animation that you want to present at the same time, you can use this transition duration. You also have access to the curves and everything. But a better way, if it's a UIKit animation, you can just animate it alongside this transition without worrying about any parameters. Let me just uncomment this code. Animates changing the background color depending on if you're landscape or portrait. So now if I rotate it into landscape, you can see that it also animated the background to be gray color. And if I rotate it back, it also animated it back to white. So you can see that that animation happened in exactly the same duration and curve as the original animation. So with that transition, you can also see that some other methods were called. What happens if I present a view modally? The default way of presenting a model is the new view controller being presented not covering the whole screen. This behavior can be disabled by making the model presentation style to be full screen. But for now, let's see what happens in this situation. As you can see, a new ID was introduced. That's how I designed the code so that we can tell which controller is which. So it went to the same stages, init, viewDidLoad, but then you can see that it also did layout pass of this views of the parent, which is 1, and then called viewWillAppear on the new screen. And then it went through all the stages as before. And then finally, obviously, you'd get viewDidAppear. Now you can notice a few things here. Because the screen was not actually covering the full screen, the old view controller never quite fully disappeared. You can see it behind here. And you have to account for this whenever you want something happening on disappear, for example. You have to make sure that the view controllers that you're showing either covering the full screen. If they're not, then your current view controller would never disappear. One common mistake that people make is using viewDidAppear for removing observers, for example. And since this is not always guaranteed to happen, it doesn't quite make sense to do it there. Instead, what you could do is use the init and the init functions to set up those observers and to remove them. Now, of course, one of the good things with this new type of presenting a model is that you can interact with it and you can just pull it to make it disappear. So you can see that once I started grabbing it, you got notified a new message there that said view will disappear. This is called on this view controller. And if I let go of it, it called back viewWillAppear and viewDidAppear. And then I can just swipe. All right, so let's see what happens if I disable this default behavior. And then I will present the model. And this time you can see that it takes up the full screen. And also you can see that the parent screen will get the view will disappear callback. And once everything completed and the new screen finished appearing, you also get the callback that the current view also disappeared from screen. So a very important change here, especially if you're relying on viewDidAppear, you will have to basically make sure that you present new screens full screen only. If you made it this far and enjoyed this video and the tips I'm showing, do not forget to hit that like button and subscribe to my channel for more content like this, or even better. Also, I encourage you to use the comment section to let me know what I missed, or if you have any suggestions for future videos. I would definitely love to hear those. So that showed us how presenting view controllers work. I want to show you another example, which is pushing a view controller into the navigation stack. I will use the second button and I will push the new screen onto the current navigation stack. So you can see that the second screen was initted, then viewDidLoad, then the first screen will get a view will disappear message because pushing it to the navigation stack also makes that previous view disappear from screen. And then it's pretty much the same thing. Another interesting thing here to note is that when you have multiple view controllers onto the navigation stack, whenever you do something like a rotation, all of those screens will actually receive that notification so they can adapt it accordingly. If I rotate it here, you will see that both the first screen and the second one received the view transition, which allows them to adapt to the new orientation. Another interesting thing with navigation stacks is that you can manually interact with the screen. And it's basically the same thing as using a model sheet when you can pull it down. In this case, you can pull it from the side. And you can see that in the console, there's a view will disappear triggered the same way as in the model one. And if I let go of it, the same thing happens. And if I continue, it behaves just like disappearing. So let's see what tips can we get out of this. Be careful what you assume is ready and when it's ready. If you want to build your view hierarchy by adding more custom views, use the viewDidLoad method. But if you also need to have the bounds ready and you're not using auto layout or it's some custom drawing code, then maybe it's best to do that in the viewWillAppear, viewDidAppear, viewDidLoad subviews, and so on, which already have the view bounds calculated. I also suggest that you take this template, which I will link down below in the description, to test as many weird scenarios that you can think of. Because what I found is trying out this type of things is the best way to learn of the lifecycle. By trying it on specific scenarios that you might encounter in your day-to-day work. Oh, I also plan to make a video about the app lifecycle. That is way more interesting, and it's also very important for you to know as an iOS developer. So see you next time.